Good morning. This is Mr. Herman here with your video on quadrilaterals. So we've spent a few weeks on proofs now, and we're moving on to quadrilaterals. We're going to need to remember some of the things that we saw from our proofs and our theorems and definitions that we've been talking about. But we're moving on from triangles and moving on to now quadrilaterals. So a quadrilateral is any figure with four sides. Any figure with four sides. Okay, quad means four, lateral or lata is sides. Okay, so the main one we're going to focus on is a parallelogram. And so a parallelogram has four sides, and more specifically, it has two pairs of parallel sides. Okay, and we'll make a note here that this is a quadrilateral. Okay, so we have a parallelogram here, and we're going to call this parallelogram A, B, C, D. Okay, so our name here, parallelogram, that's kind of what the shape of a parallelogram looks like. A, B, C, D. Now, we're going to talk about the characteristics of this parallelogram. So, first off, we know that pairs of opposite sides are parallel. Okay? So, we can show that with our arrows. So, I have one arrow on each side here, and these opposite sides is on the bottom, is on the top. Okay, this side over here, CB, is on the right. It's parallel to DA, which is on the left. Okay. So we can make those statements then that AD is parallel to BC, and then also that AB is parallel to DC. Okay. So opposite sides are parallel. We also know that opposite sides are congruent. Okay? So what that means is that AB and DC are congruent. Okay? Now notice how I'm continuing to use my markings. Okay, so one mark is congruent to one mark. And then I'll have two marks over here and then two marks over here. So I can now make the statement that AD is congruent to BC. Okay? Now, we're moving right along to our angles here. Pairs of opposite angles are, so that would be angles that are across from each other in our parallelogram. These angles are congruent. Okay? So, if I'm going to my opposite angles, I'll have angle A and angle C. They're across from each other in my parallelogram. And then angle D, I use different markings to show that it's a different angle. And angle B are congruent because they're across from each other as well. Okay? So, let's see, we've got angle A is congruent to angle C, and angle B is congruent to angle D. Okay? Now, if we're looking at these two angles right here, angle A and angle B, okay? Now, a triangle has 180 degrees in it. If we look at a parallelogram, I'm going to go ahead and draw a couple lines in our parallelogram. If I put a line here, okay, I have two triangles. We know that 180 degrees are in one triangle, 180 degrees are in another triangle. So two triangles together is going to make 360 degrees. So what we know then about our pairs of adjacent angles, that means angles that are next to each other. So A and B are going to be next to each other. B and C are next to each other. C and D are next to each other. And D and A are all next to each other. Those angles are supplementary. Okay, and do you remember what supplementary means? Hopefully, we said that that is angles that add to 180. Angles equal 180 degrees. Okay? So that's going to be an important feature as we move along. Okay? Now, we were talking about diagonals. So I went ahead and already drew in one of our diagonals, AC. And I'm going to draw on our other diagonal, DB. Okay? And I'm going to put a point in here, and I'm going to call it point M. Okay? So the diagonals are not congruent. Okay? The diagonals are not congruent. So if we can look here, this clearly looks like this diagonal AC is going to be longer than the diagonal DB. Okay? So our last characteristic about our parallelograms is that the diagonals bisect each other. Okay? So, we remember what bisect means? So hopefully you chose that bisect means to cut in half. Okay? So what that means here is that DB is going to bisect AC, so AM is congruent to MC. And then DM is congruent to BM. Okay, so we're going to put those down here before we move on to several problems. So AM is congruent to CM, and BM is congruent to DM. Okay, so we're going to go ahead and move on to some problems now. And these problems are all going to depend on knowing these 6 characteristics that we just went through. Okay, so let's go ahead and work out a few problems. Okay, so in these problems here, we're going to just say already that all the figures are parallelograms. Okay, so let's go ahead and work through these. We have angle U and angle T. So they are next to each other. They're what we would call adjacent angles. So that means that angle U plus angle T equals 180 degrees. We know that 86 degrees plus angle T equals 180 degrees. We can subtract 86, and we know that angle T equals 94 degrees. Oh, losing some focus there this morning. All right, there we go. Okay, 94 degrees. So, let's go ahead and look at the next one. We have parallelogram GFEH, and we know that one side is 8, and we're trying to figure out what the length of the opposite side is. So if we think back to our properties, our first property, our second property was that pairs of opposite sides are congruent. Okay, so GF and HE are opposite each other. That means that question mark is going to equal 8. Okay. Now, we're going to kick it up a little notch here. Now, we have parallelogram XUWV. Or XUVW, sorry. We have angles that are across from each other. Okay. So, we use the word opposite. So, angle W and angle U, they're across the parallelogram from each other. So, across the parallelogram means that they're going to be equal. So, that means that 11x plus 3 equals 80. Okay, so we're throwing it back to our solving equations. We're going to get our x by itself. Subtract 3 on both sides. Okay, 11x equals 77. And then we're going to divide by 11 on both sides. And so x will equal 7. Okay. Now, once again, we're working with our congruencies. We said here that our opposite sides are congruent. So kind of like the one we just did above here. But in this case, rather than just have a question mark and a number, we have a little more of an equation to work with here. Okay, so let's go ahead and do what we did here. We said question mark equals 8, and we were good on the first one. Now moving down here, since UR is a opposite TS, we know that 5x minus 6 equals 4x. Okay? So I'm going to go ahead and get my x's all by themselves on the right side since I've already got only x's on the right side. And I'll do minus 5x on both sides. Okay, so I have minus 6 on the left. 4 minus 5 is going to give us negative x. And I'll go ahead and divide by negative 1 on both sides. And then x will equal positive 6. Okay? So notice one thing is that with our side lengths, and we'll see this as we move on, we are going to continue to have sides that are congruent as long as they're opposite each other. Okay, our angles can be supplementary or congruent, as we'll see as we move on as well. So we'll move on to a slightly more challenging one right here. Okay, so we have parallelogram FGDE. Okay, and we are asked to find the value of x. Now we have a diagonal drawn here from F to D, so diagonal FD. And so we've got 3 different angles here. Angle E is adjacent to this big angle EFG, okay, which is made up by smaller angles of EFD. There's our small angle EFD and our other small angle GFD, okay. But this makes up the big angle of GFE, which is going to be supplementary because it is adjacent. So since angle E is next to this big angle over here, we can add all 3 of these angles together. So we have 92x plus 1 plus 45 plus 41x plus 1. And since they're adjacent, they add up to what? Hopefully you said 180 degrees. Okay, so I'm going to combine my like terms here. I got 92x and 41x. Okay, since they're both on the left side of the equal sign, I'm just going to group them together. I'm not going to subtract to the other side. So let's see, I have 133x here. And then I'm going to also group my numbers together. That's going to be plus 47 equals 180. Okay, I'm going to move my numbers onto the right side since I got only x is only on the left side. Okay, so my plus 47 minus 47 zeroes out. 133x equals, how convenient, 133. And then divide by 133 on both sides. And so x equals 1. There we go. Okay, so in this case, we equal 180 degrees because we have adjacent angles. We'll move on to one with some diagonals in it. Okay, get some emerald here. Bam, we're kicking up a level. I got some diagonals here, and we know that US is 30. We know that GS is 3x minus 6. And we know that if diagonals bisect each other, that means that for this whole length here, this and this must be equal. Okay, so we know that GS is 3x minus 6. We know that US, the whole length, is 30. Okay, so let's see. We know then that 3x minus 6, I can times that by 2. And that should equal 30. Okay, because this 3x minus 6 is GS up here. But since this is congruent to it, it's also 3x minus 6. So I have 2 of those lengths. So 2 times 3x minus 6. Now we're going to go ahead and distribute, which we want to multiply on. Okay, so 2 times 3x gets me 6x. 2 times negative 6, make sure I keep my negative, minus 12 equals 30. We'll add 12 on both sides. And I'm left over with 6x on the left and 42 on the right. Divide by 6, and x equals 7. All right, so we have one last problem to go through, and it's real similar to what we saw earlier. The only difference here is that we're trying to find xw. So earlier we were just solving for x. Now we're trying to actually find the length. So it's just one extra step that we have to work through. Okay. So as we recall, we have sides that are opposite each other. xw is opposite yv. So if they're opposite sides, that means they must be equal. So 4x plus 3 equals 5x minus 1. I'm going ahead and subtract 4x from both sides. So I can zero out my x's on the left, 3 on the left, with x minus 1. Let's get x by itself, so plus 1 on both sides. X equals 4. Okay, now we're not done yet. We still have a little bit more to do. If we know that x equals 4, we can find xw by plugging into our expression there. So 4x plus 3, 4 times, since we know that x equals 4, I'm going to plug in a 4 here, plus 3. So I get 16 plus 3 and 19. Okay? So go ahead and work on the practice to the end of class today to get a better understanding of how we can use our parallelograms.